Welcome you all for the afternoon session of day 5. Session 15 will be on Introduction to Time Series and Spatial Data Analysis. It will be handled by Dr.D. Saraswathi. Today we are pleased to welcome our resource person to the gathering. Dr.D. Saraswathi is currently working as Senior Training Associate from Scientific Computing Solutions, Chennai. She has completed her PhD in Efficient and Intelligent Computer-Aided Diagnosis System for Mammogram Analysis. Her area of expertise includes data science, predictive analysis through artificial intelligence, machine learning, and deep learning. She is a techie with proficiency in R, JavaScript, MATLAB, and Python for machine learning and deep learning. She has published 36 research articles in various reputed high-impact journals. She has received the Best All-Rounder Award in the Master of Engineering in Applied Electronics and Academic Meritorious Award in the undergraduate program. We are humbled by your presence, ma'am. Now, I would like to request our resource person, Dr. Saraswathi, to take over the session. The session is all yours, ma'am.
Yes, ma'am. Thank you, ma'am. Thank you for your very nice introduction. Am I audible, ma'am?
Yes, ma'am. I
Yes,
can
ma'am.
hear.
Yes, ma'am. So this is Dr.D. Saraswathi here. Yeah. So I'll share my screen now. So our today's topic is all about time series and spatial data analysis. Um, because this is a afternoon session, post forenoon session, so it will be very difficult for you. But even then, I'll try my level best not to making you to sleep. Okay. Okay. So we'll be concentrating mostly on time series analysis, and then we'll move on to spatial data analysis. Okay, so my dear participants, do you know what is this time series? How it differs from the conventional methods or conventional algorithms or conventional regression and classification techniques? What is this time series? Anybody know? Can anybody tell me what is this time series? What do you understand from this? You can put it in a chat. Yeah, somebody is telling I'm not audible. I'm not hearing. Is it from my end?
Your voice is clear, ma'am.
Okay.
You're audible.
Yeah, ma'am. Okay. So I'll present my screen now. Yeah. So just I'll tell you. Yeah. So let me give you a small note on this. What is time series, and then we will move on to hands-on session with the Python. Using Python, we'll be doing some of the uh, programming side. So let me tell you what is this time series. Okay. So time series is a sequence of observations over a certain period. So for example, I can note down all the temperature day by day for the past 20 years. I can note on the temperature which is happening in Puducherry. Likewise, I can go for a sequence of observations over a certain period. It is not restricted to 1 year, 2 year, or 3 years, not like that. It may be of 10 years, it may be of 20 years. For example, you can also record the observations of seismic signal for the past 20 years, so that you can predict the next forthcoming seismic problem. Okay, yeah, earthquake problem or whatever may be. Okay, so I'll tell you one simplest example for a time series. Okay, so we all have come across on a day by day, day to day basis is the change in temperature. Okay, change in temperature. So the previous day we'll be having some other temperature. In winter season we'll be having some other temperature. So today we'll be having some high temperature. Okay, so throughout the day we can take, or throughout a week we can take, or throughout a month or year, or 10 years or 100 years we can take. Okay, so we need to record the observations of the temperature with respect to time. So that's why we are calling this as a time series. Okay, so we can call this data as a temporal data. So how to analyze this? So for example, if I want to know, if I want to do the weather prediction, so what will be the weather tomorrow, what will be the temperature tomorrow, if I need to know, how can I use this machine learning for this prediction? Yes, I can very well, you can go for time series prediction. Okay, yes. So the analysis of temporal data is capable of giving us useful insights, okay, on how your variable changes over a time, how the temperature is changing over the time. Okay, so this session will tell you, or I can say the message takeaway from home, takeaway to the home from this session is how to analyze and how to forecast the time series data with the help of various statistical models are there, right? So various statistical model like moving average model, Larima model, Larma model, so many models are there, so many statistical models are there. And we'll also be seeing about how this machine learning models are help us to predict this time series, okay, in an elaborate and easy way to understand. Okay, yes. So this session is purely who is looking for understanding the time series and time series forecasting models. So I'll tell you from the scratch, so you don't worry about this. If you have any doubts, you just please you just let me answer your question.
Excuse me, ma'am. Sorry to
Yes, ma'am.
interrupt you. Your
Yes, ma'am.
presentation is not visible. Can you please share it again, ma'am?
Yes, ma'am. Yes, ma'am.
Yeah.
I'm not able to share, ma'am. If host is sharing their screen, ma'am. Yeah, now it is
Yeah.
possible for me. Yeah, yeah, yeah. Now it is possible for me.
Okay.
Yeah. So is it visible now, ma'am?
Yes, ma'am.
Is
Yes.
my size is okay?
Yeah, it's good, ma'am. Thank
Okay.
you.
Okay, ma'am.
Yeah. Okay. Okay. So here I'll start with what is this time series? Um, and yeah. So what are the programming languages that we can use to predict this time series? What are the programming language that you know? But basic understanding of any programming language is essential, right? Whoever may be, basic understanding of any programming language is essential. Whether we want to work with it or we want to develop some machine learning problems or whatever maybe. Okay, okay, I'll tell you the preferred programming languages. Okay, for example, the first preferred language is Python. You all know it is a high level interpreted programming language. It is very fast and very, very easy to code, and it is following either procedural or oops concept, oops paradigms. Okay, so the way actually Python has a variety of libraries which actually makes us very easy, but the procedures are very simple. Okay, so we'll be coding in Python in this whole session, and I'll tell you about the libraries which are useful for time series modeling and all. Okay, okay, the second language which is very suitable for use for doing program for this time series modeling is R programming. So it is similar to Python. It is also an interpreted multi-paradigm language which supports the statistical computing and also the graphics. Okay, so various packages are available in R language and it makes easier to implement the machine learning model as well. Okay, my third choice is Java. So Java is an already right. Java is basically a OOPS concept, that is object oriented programming language. It is interpreted language, which is widely famous for a large range of package availability and sophisticated data visualization techniques. And but my next choice is maybe C C++. So see, you all have known about this language. These are compiled languages. These are the two oldest programming languages, and these languages are often preferred to incorporate machine learning capabilities in the already existing applications as well. Okay, and the next one is MATLAB. So as we are academicians, always they will prefer MATLAB. MATLAB is a matrix laboratory. It is a multi-paradigm language which gives functioning to work with the matrices, right? So it allows all the mathematical operations for complex problems. And it is primarily used for numerical operations. We can also implement all those machine learning and deep learning algorithms, even for time series modeling using this MATLAB. And these are the programming languages, I can say. These are the preferred programming languages. Other than that, there are some of the languages available: JavaScript, Prolog, SQL, Scala, Julia, SAS, etc. So for statics and all, we'll be using this SAS programming language. Okay. Yes. So as you all people know, all the libraries which are present in the Python. So day by day, any one of the libraries coming up, right? So the developers are developing many libraries and they are introducing day by day. So Python has an established popularity among the individuals who is performing this machine learning, because it is very easy to write and also easy to understand the code structure. So whoever, if you know English, you can understand Python, right? And as well as variety of open source libraries are there. I'll tell you some of the libraries. All must have known this NumPy. So NumPy is a numerical Python library which is used for scientific computing, right? It works on n-dimensional array object and provides basic mathematical functionality such as we can measure size, shape, mean, standard deviation, minimum, maximum. We can calculate any of these functions. Okay, even if we go for complex functions such as Fourier transform, you can use this NumPy to do that. Okay, and then the next library, the most efficiently used library is Pandas. This Pandas, it provides highly efficient and it is easy to use the data structures, right? So for example, if I want to have a data frame, I can use this Pandas. Or if I want to retrieve some values from the panels, I have to use this Panda library. Okay, so it has enhanced Python's functionality for mere data collection and preparation to data analysis. Okay, so that these two libraries, no, these one is Pandas and an NumPy. We can use it for even a small data set. Even we can use this Pandas and NumPy for any kind of large data set as well. Okay, yes. And the third library is SciPy. SciPy is the abbreviation for the SciPy is Science Python. Okay, it is a library used for scientific and technical computing. Okay, so this is particularly useful for doing the functionalities like optimization, signal and image processing, integration, interpolation, and for all those things we'll be using the SciPy. Okay, and you might have come across this library, scikit-learn, right? The scikit-learn library is widely used for statistical modeling, machine learning, and deep learning. Okay, so you might have come across this scikit-learn for the past few days. For the past 4 days, all the resource persons have taken this machine learning and deep learning. You might have come across this library, scikit-learning. Okay, so it is useful for modeling your data for regression, classification, and clustering models. It works well with NumPy and Pandas and also other libraries, which makes it easier to use. Okay, and the next library is so if you want to go for some statistical data exploration or statistical modeling, so there is a library called stat models. Stat models. We'll be using this library in the forthcoming Python programming. Okay. It also operates well with other Python libraries. So it is very useful for statistical modeling. And then, yes. Can you tell me which library is used for data visualization? You kindly put it in a chat so that I can see.
You can use CBOM, huh?
Pardon, sir?
CBOM for data. CBOM.
Yeah.
CBOM or
CBOM.
Matplotlib.
Matplotlib. The most widely used one is Matplotlib. Okay.
Yes, ma'am.
Yes, sir. I'll share this. Yes. Just a second. Yeah. So Matplotlib. So this is specifically for data visualization. So without visualization, so we cannot know, right? We may not be able to interpret how the data is, how the plot is, how it is getting distributed. Everything we may not be knowing, right? So this is a widely used library which is called Matplotlib. We can visualize this in various formats. You can plot line plot. You can plot as a graph, that is bar graph. Even you can plot as a heat map, scatter plots, histogram, etc. Okay, so it contains all the graph related functionalities which is required for plotting to labeling. Okay, so these libraries, the aforementioned libraries are very essential to start with machine learning with any sort of data. Okay, and another one more library is there. Especially we'll be using this library, date time library, because it is a time series sequence. We are going to deal with the time. With respect to time, we are going to plot the data. So this library, which is called date time library, it has two modules. One is datetime and another one is calendar. It provides all the necessary datetime functionality for reading, formatting, and manipulating the time. So we'll be using this datetime library. I'll be explaining you. Okay. So now I'll tell you, time series is a sequence of observations with respect to time. Okay. So the order or any continuity, it should be maintained in any time series. So that's it. So the data set may be univariate or multivariate time series, but univariate is a value with this which we are going to record with respect to time. If it is a multivariate, we are going to plot, or we are going to record multi values or multi variables with respect to time. Okay, so multivariate time series having hardly data for approximately 1 year will be doing. Okay, so now I'm going to take a data set which is a multivariate time series data set. Okay, so actually this is air quality data set. We are going to take it out. We have taken I have downloaded this data set from Kaggle, or you can download from Google itself. You can download. Okay, air quality data. So for 1 year they have observed, they have recorded the data with respect to time series, and they have tabulated like this. All these data sets are in CSV format. So I hope everyone might have come across this CSV file, that is comma separated values. It is nothing but an Excel file. All your data will be embedded in your Excel file. That's it. Okay. So this particular data set, it represents the pollution which has happened in the Italian city. Okay, you can download. Even I can send you the link so that you can download that particular. Yeah, I'll send you through chat so that you can download it. I'm not able to send the message. Yeah. So you can download from this data set. Yeah. Now I'll just explain you how to input the data using Python, and what we are going to visualize in this data. I'll explain you all those things. Okay. So we need to make sure that the time series is equally spaced, and the second point is there should not be any redundant values or gaps in it. Okay. So in case if the time series is not continuous, we have to upsample or downsample the data. So you have to note down all these points. So if you're having a data, if you are having some time series data, one should understand how to interpret the data. So without interpreting the data, we people cannot do any research, or we cannot understand anything, right? Okay. So first, let me explain you. Yes. Yeah. So let me explain you how I'm going to proceed with this. So first, I'm going to input the data. Okay. So while explaining the program, while explaining the Python program, I'll be telling you the concepts also. So if you have any doubts, you please stop at that point. I'll be explaining you what's happening over there. Okay. Yes. So this is a Python language. I'm going to show you the time series modeling using Python, and I'm using this Colab, Google Colab. Google Colab is easy because at any point of time you can retrieve that particular Python notebook from your Google Drive. You can import data or whatever may be. So it is easy for the academician or easy for the researchers to handle with this Google Colab. So many of the libraries are actually inbuilt. So that might be easy for you. So you may not have any error using this Google Colab. Okay. Yes. So here I have uploaded the data, air quality UCI.CSV. I have uploaded the data. So how to upload the data? You just in the left hand side, there is a folder like a symbol. You just click this folder. Is it visible, ma'am?
Yes, sir. Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
yes, ma'am.
Yeah. You just click this folder. So it is just like a folder. You just click this. You people will be having only the sample underscore data. It is an inbuilt data set. Okay. If you want to upload a data set and if you want to run it in your environment, then what you need to do is you click this upload session, upload it to session storage. This symbol in the left hand side, you just click it, and then you'll be able to locate your folder so that you can upload that particular file. That CSV file can be uploaded. For example, book sales channel or whatever may be the thing. Okay, so here I have uploaded this air quality UCI. There are two files. One is CSV file and another one is XLS. Here I have uploaded this air quality UCI file and then just make it as open. Now it will be displayed here so that you'll not be getting error in your program. Okay, yes. So first what I'm going to do is I'm going to import the pandas. So as I told you, pandas is for data structure. Okay, so if you want to read the file from CSV file or whatever may be the file, you need to import the data, but you need to import the pandas first. Okay, you can make it as pandas as PD. It is as your convenience. Now what I'm going to do is I'm going to read that particular Excel file or CSV file. So for that, the inbuilt library is read underscore CSV. So what I'm going to read using this panda library, panda function, I'm going to use this. I'm going to read this CSV file. So you need to put pandas dot read underscore CSV within bracket. What you need to do is you have to tell the file name. There are so many CSV files, so you need to tell the correct lowercase or uppercase, whatever may be the thing. You have to put a correct file name dot CSV, comma. Okay, so here what I'm going to do is I'm going to locate this particular column, SCP and decimal, and then I'm going to display it in the later line. I'll be displaying what is actually how the file will be. I'll be displaying that. Okay, and I'm going to store the particular file. I'm going to store the particular CSV file in DF. Okay, so DF means like it is a data frame. You can use any variable. Okay, and then what I'm going to do, I'm going to locate. Okay, I'm going to locate that particular columns and rows. So all rows I'm going to locate, and then columns is this is the starting point and this is the ending point. So starting point, I'm going to start with all the points, all the rows, and end with 0 to 14. 0 to 14 means we'll be having 14 columns. Okay, so now I'm going to run this particular line. Okay, so yes, so when you run this particular cell, automatically RAM will be allocated for you. Cloud RAM will be allocated for you and disk storage will be allocated for you. So if you move your cursor here, you will be able to see how much RAM you're having, how much hard disk it is allocated for you. So RAM is 1.85 GB and hard disk is about 41.69 GB. Okay, yeah, so now we are connecting to the cloud. Okay, just I want to interpret the data what I have uploaded. Okay, I want to know what is the length of that particular file, the number of rows. So the number of rows, for that you just use this function len df. So length df means the particular file, how many rows are there. If I want to calculate, I can write this particular cell program. Okay, and then it is listed as 9471. So there are 9471 rows are there. That much data is available in this particular .csv file. But I want to see what is over there. Okay, so for that, use that variable df.head. Head means it will display you the first 5 rows in your CSV file. let me run this particular cell. You can see here. Okay, with all the date, all the time, column, everything, it will be displayed over here. Okay, yes. So by saying this, I can understand all these variables or all these parameters are observed here with respect to date and time. That is it. Okay, yes. Now what happens is, we may not be knowing, so you cannot check by manually 9500 rows. You cannot check whether there is a if there is no number, that is NaN, it will be displayed as NaN. It is not a number. Whether it is display, whether it is there or whether it is available there or not, we cannot manually check, right? So I can write a program, Python program, to check that NaN, which is not a number. So for that, you use that variable df dot is not available. Okay, IESNA, the empty bracket dot sum. Okay, let me run this cell. Yes, now you will be able to see the data type. It is of integer 64, and all those date, time, these are the parameters I can see. I can sum it up and I can see all the values are displayed over here. Okay, and then what I'm going to do is, I take the variable, I take this particular column, date column, okay, 114 columns, 114 rows, and then I'm going to check whether there is any whether there is any not a number option is available or there. I'm going to check. So let me run this cell, and I'm going to check whether it is not available or not. I'm going to make it as 0. Okay, I'm going to make all your values as 0. So for that, I'm going to write dot not null. So now you see all your parameters are values are 0. All your parameters there. So there is no not a number is available in this particular data. You can observe from this. Yes. So the next is, so always we need to pre-process the time series, right? So that's what we have done now. That's what we have done now with respect to this NaN values. If there is any NaN values, we have to replace them either with a 0, or you can also replace with average, or you can also replace with preceding or succeeding values. So always you go for replacing. Okay, replacing is a preferred choice over dropping, so that the continuity of time series is maintained. You don't drop any data, just you replace all those NaN values with 0. That's it. Okay, so yeah, you can understand, right? 114 values are there. 114 values are NaN values. So I'm going to make all these 114 values to 0. So that's what we have done here. Yes. So if you are having NaN values in the last step, okay, last few values, if it seems to be null value, then you can go for dropping. So there, dropping will not affect the continuity. Particularly, you please keep it in your mind that in time series modeling, the continuity is important. Okay, yes. So now we'll try to plot all these line graphs against the time, so that you can understand well what is happening over there. Okay, so for plotting, we'll try to combine this date and time column. Okay, and I can convert this, we can be able to convert this particular two columns, right, date column and time column, into a single object. So that is called date time object. I told you about the library, right, date time, in the starting of the session, right? So it is called date time. So that date time, it is actually an object. It is from a string. We are going to frame this datetime library, datetime object, right? So this can be accomplished using this datetime library. Okay, so what I'm going to do here is, in my program, I'm going to converting this date column and time column together as an object. Okay, so for that, what I'm going to do is, you just take this particular column, df.date plus, right, and I'm going to append with this df.time. Okay, and I'm going to store this two values in a particular column, that is called date time, and I'll be trying to print this particular date time. If you want to know what is the type of that particular date time column, automatically it might be string. Okay, it came from a class, it is a string because we have appended like that. Okay, so now what I'm going to do is I'm going to import this particular library, date time library. Okay, so you go for import date time. So else if you have not uploaded this library, it will throw you error. So you please make it sure that you have uploaded this library and import it. Okay, import date time. So what happens over here? Let me run this cell and I'll show you the output. It's a kind of panda library. Okay, it is taken from the timestamp, right? Now let me see how variables like temperature changes with a change in time. So I'll be plotting the date time. I'll be plotting using this datetime library, and then I'll show you how it is getting plotted over there. Right? Yes. Now let me take this. It is stored in the variable called datetime. Okay. Yes. So this is a variable, right? df.datetime. So that will be stored in the particular index, df.index. And I'm going to use this matplotlib library and I'm running this. Yes, now you can see and you can interpret over here. So using this matplot library, I am plotting this date time column with respect to time. Right. Yes. So you can see over here, this is the temperature value and this is the year value. Okay, date time value. Because we have used a date and also the time, it is listed as 2004 to 3, 5 to 4, 7 to 4 to 7 and 4 to 9, 4 to 11 and 5 to 1 and 5 to 3. Okay. Yes. And I am trying to plot this particular column, that is C6H6 is particular feature. I'm going to display this. It will also be looking like this. And you can infer here, you can interpret the data as well. It is between 0 to 25 or 0 to 40. The temperature is between 0 to 50 and sometimes it falls to negative values. Sometimes it falls to negative values because if it is so chill or if it is a winter season, then the temperature automatically it goes down, right? It refers to your temperature data. So if it is a air quality data, then automatically air quality data will also be as well the same like that of your temperature. So whatever may be the parameter values, we are going to plot it with respect to time. Okay. Yes. So this is C6H6 it is one of the column which we have displayed in the earlier cell. Okay. So if I want to plot this particular, you put that parameter within a string and then you make it as df. Df is a variable which we have declared over there and I'm going to plot it. If you plot like this, it will be like this. Sometimes it falls to negative values. Yes. So sometimes we need box plots, right? So box plot is another useful kind of graphs that allow you to condense a lot of information together about a data set into a single graph. Okay, I'll tell you. It shows the mean, 25% and 75% quartile, and outliers of one or multiple variables. It will be showing all these things together in a single graph. Okay, so for example, in some cases when number of outliers is few and is very distant from the mean, we can also eliminate the outliers by setting them to some mean value or some quartile value. We can do all these things with respect to box plots. Okay, so here I'm going to run this particular cell. It will show you the box plot. Yes. Yeah. So here you can interpret from the figure that some of the values are outliers. Okay, you can see some two data are present over there in minus 200, right? So we can omit these outliers and we can take the other data and then we can predict the next incoming data. So that is what happening over here. Okay, so you can also use this kind of plots to interpret the data, right? Yes. Now comes to the main theme of our session, time series modeling. Okay. So as I told you, it is a record of observations with respect to time. we are taking, we are seeing this multivariate time series modeling. Okay, whatever may be the time series data, it will have 4 components. One is level, trend, second one is trend, third one is seasonality, and another fourth one is the last one is noise. So what is this level? Okay, from the word we can understand, right? It is the mean value around which the series varies. It is a mean value or average value. So around which the series will vary. For example, if it is a if it is a month of May, okay, always the degree will be, the temperature will be about some 30 degree or 40 degree centigrade, right? So it will vary around the mean value. Okay, if you take from May 1 to May 30, all these 30 values of your input data, it will vary around this value, right? Around the value of 40 degree centigrade or 25 degree or 30 degree centigrade. Okay, this is called a level. So the second component is trend. So what is this trend? It is an increasing or decreasing behavior of a variable with respect to time. Okay, so for example, even in May month, we'll be having some rainy day, right? So in that particular rainy day, the behavior of your temperature will get decreased. At some time, we'll have some that particular 1 week day, right? In Tamil we'll call Katri Veil, right? So Nakshatra Veil அப்படின்னு சொல்லுவோம் இல்லையா? So in those days we'll be having the temperature which is increased far from the mean value. So that is called a trend. Okay, so it is the increasing or decreasing behavior of a variable with respect to time. Okay, and then the third component is seasonality. Okay, so if you go for a silk shop, right, silk sarees shop, right, always if you want to predict the product demand in that particular shop, or how much over turnover is happening over there in that particular silk shop, silk saree shop, we can go for this component that is called seasonality. Okay, so if it is what is that, if it is January or if it is May or if it is in between those months, the sales may be very high. Okay, it is a cyclic behavior of time series, right? So that particular component is called seasonality. And the last one is noise. It is an error in the observations added due to environmental factors. Okay, due to the environmental factors, some of the error might have occurred in your data, in your time series data. Okay, so with all these components, how to model my data, how to model my data using some machine learning algorithm or some statistical algorithms, how to do that. So the available modeling techniques, time series modeling techniques, are the very well-known method which is called naive methods, auto regression model. In digital signal processing, you might have come across this auto regression model, Larima model, and exponential smoothing model and all. So these comes under this statistical modeling. And this LSTM, it comes under the recurrent neural network. It comes under neural network, right? It comes under the deep learning part, that is RNN part. Okay, so we can model our data, or we can predict the temperature, the next day temperature or the next year temperature, whatever may be, by using all these techniques. Okay, so we'll go one by one. So first we'll start with this naive methods, right? Okay, so in naive methods, what I'm going to do is I'm going to use this NumPy library, okay, and I'm going to calculate the mean, standard deviation, right? And I'm going to display the maximum temperature, minimum temperature, all those stuffs. Let me run the cell. I'm going to print the value. Okay, here we can see the maximum temperature is 44.6 and minimum temperature is minus 200 degree, right? So you have observed from this particular data, right? From the graph, you might have observed, right? Yeah, so you can see here the maximum point is 40, right? Here the maximum point is maybe 44 or something. The lowest point is, the minimum temperature is minus 200. Okay, yes, so the mean value is around 9.77 and standard deviation is 43. All these are statistical values. Okay, so actually, what is this naive method? These are called estimation techniques, such as the predicted value is given the value which is equal to the mean of preceding values of the time dependent variable are calculated. Okay, these are used for comparison with sophisticated modeling techniques. Okay, and then what is the next one is yeah, we'll be shifting a particular data. We are going to lag the data by once. So this is denoted by the letter T. Yes, so I'm going to store the value in the letter T, a variable T, and I'm going to shift once, and then I'm going to store those datas in T minus 1. Okay, let me run this cell. Yeah, now what I'm going to do is I'm going to use this name method. Yes, I'm going to take all those data. This is the actual data, and this is the um, uh, that is lagged data by means of 1. Okay, and I'm going to predict the value, or I'm going to print the root mean square error value. What is the error which is going to happen by using this naive method. Okay, so for that, what I need to do, I'm going to import this particular matrix using this sklearn library, that is scikit-learn library, and I'm going to use this square root, that is sqrt. I'm going to import from math library. All these steps I'm going to do, and I'm going to use this variable df underscore name, and I'm going to predict. Okay, this is stored in the variable called prediction, and I'm going to calculate what is the error. Okay, so that is very important so that we can correct ourselves. I'm going to calculate root mean square error for my naives method. Okay, so for that, it is calculated using this formula, right? Square root matrix dot mean underscore squared error underscore error. This is an inbuilt library which will calculate the root mean square value. Okay, so between which data and which data I'm going to predict? Between my actually existing data, that is true data, and then my prediction, that is predicted data. So between these two data, I'm going to calculate this root mean square error value. Let me run this cell, and my RMSE value for naive method 1 is 12.9. Okay, so from this I can understand what is the error and what is the root mean square error, and how to correct all these stuffs. Okay, so let's see the next naive method, where predicted value at present time is equated to, actually there are two parameters, right? One is time lag parameter, and another one is, we can also will go for some other features also. Okay, so here we'll be seeing the next naive method, that is number 2, where predicted value at present time is equated to the mean of the time periods preceding it. We'll be calculating all the means, and then we'll be trying to predict the value at present time. Okay, and we'll be calculating RMSE value also. Okay, so here in this second method, what I'm going to do is I'm going to calculate the mean and shift, and then it is going to store in that particular variable, and then I'm going to calculate this RMSE. Okay, let me run this cell, right? So yeah, so it is stored in the variable called true, right? And I'm going to calculate this error. So this is the library inbuilt function I'm going to use, matrix dot mean squared error between this true data and then predicted data. Now if we see the RMSE value for the same data set, it is about 14.95, because here we have taken the mean and then we have calculated the error. We have shift and we have calculated the error. So while taking the mean, the error might be more. So we are taking value of mean and we are going to compare with all the data which is available in the data set. So that's why the error is increasing here. Okay, yes. So now what is this auto regression? Can anybody have come across this word auto regression? Yes. Auto regression. So here auto regression means it predicts the values of future time periods as a function of values at previous time periods. So we'll be considering both the past value and the present value and the future value. Okay, I'll repeat you again. Auto regression, it predicts the values of future time periods as a function of values at the previous time periods. The value which is going to compare between the future time period as well as the previous time periods. We will be considering the previous time periods in order to predict the future time periods. That's it. Okay. Simply I can say x of t plus 1 can be predicted by using x of t minus 1. That's it. So predictions of auto regression may fit the data better than that of naive methods. Okay, but this kind of methods, it will not be account for seasonality. Okay, because continuity will not be there in seasonality. So it will go for, if you go for other three components, it works well, but it may not be able to account for seasonality. That is it. Okay. Yes. So here I'll tell you. Yes. Auto regression. Here we'll be considering. Here we will be considering a stationary time series. There are two types of time series. One is stationary time series and another one is non-stationary time series. Stationary time series will not change with respect to time, but non-stationary time series data will get changed depend upon the components what we have seen. Okay. So an auto regression model sees the value of the variable at time t as a linear function of values p time steps preceding it. Okay. Here we'll be calculating the auto regressive trend parameter, and we'll be using this white noise, white Gaussian noise, all those stuffs in this auto regression or auto regression. The value of p can be calculated using any kind of methods, any various methods. Okay, and I'll show you the plot now. Yes. So here, what I'm going to do is the formula which is going to calculate about the auto regression. It is length of your DF. It is about some 9,500, right? So that will be taken into account here, minus integer into 0.2 into length of DF, right? And then why I'm going to take all these data is I'm going to split it into two. So one is for testing data and another one is for training data. So we may have a question. So how to split, and how much percentage we have to split it for training, and how much data we have to split it for testing. Everyone will have that question. Okay. So by trial and error method, you just adjust the hyperparameters in your machine learning models, and then you try to split the data. So you start with 60-40 or 50-50. Okay, 50% of your input data for training and 50% of input data for your testing. And then you go for 60-40 and then 70-30, 80-20. So maybe 80% of your data for training and 20% of data for your testing. You can go like that. So first thing in auto regression we need to do is we need to split this. Yes, the splitting has been done over here into train data and test data. It is stored in the variable train and also it is stored in the variable test. Yes. So next comes the library. This is called stat models. As I told you in the earlier session, stat models is a library where we can plot the graphics, graphs, all those stuffs, right? And I'm going to import this particular function, plot underscore ACF function. Okay. So I'm going to take this train data alone. Okay, and here I'm going to consider the lag parameter as 100, the integer as 100. I'm going to plot it for all the 100 values. Okay, and here I'm going to use this autocorrelation method for this auto regression. And if I'm plotting this, I'll be able to understand what's happening over here. Okay. Yeah, all the lag values lying outside the shaded blue region are assumed to have a correlation outside the blue region, right? So here in the x-axis, some blue region is available, right? So all the lag values which is lying outside the shaded blue region, it is assumed to have a correlation of your input data values. Okay. So the next is, now we'll try with moving average. Okay, and then we'll try to plot it and we'll interpret the data as well. Okay, so you need to use the same library, stat model library, and I'm going to use this same plot underscore PACF function. Right here, this is ACF, right? Normal ACF function. And here I'm going to use this PACF function and I'm going to plot it. Now we can see. Yes. So actually it means this. What is this moving average? Okay. So for a, actually we have considered only the stationary time series, right? So for a stationary time series, moving average model, what it will do, it will average and then it will get shifted. It will average and then it will get shifted, right? It will seize the value of the variable at time t as a linear function of residual errors, right? Here we need to consider the errors from all the time steps that we are proceeding. Okay, so the residual error here is calculated by comparing the value at the time t to moving average of the values, which is going to proceed further. Okay, so here we are going to plot this PACF, partial autocorrelation plot, which shows the relation of a variable with itself because it is autocorrelation at a particular prior time steps, and then with indirect correlations, all those data are removed. Okay, and then we are going to plot it here. So partial autocorrelation is read in the same way as a parallelogram. The same thing, same plot, we can make it out. Yes. So this is all about this moving average. So our interpretation and our plot will be differ for every techniques, right? So if you are using this auto regression, then we'll be able to interpret the data. What are the things which are correlated together, and actually the data is autocorrelation itself. Because why it is said to be autocorrelation? What do you mean by autocorrelation? It will try to measure the similarity between itself, right? Because the first data is getting correlated with the second data, because I am going to predict the future data with respect to your previous data. So always the correlation will be there in your time series. Okay, so we can use this particular stat model in order to interpret the data. Okay, same like the moving average, we can also calculate and we can see what happened over there. In this, we can interpret over there from the data. Okay, so the next is ARIMA model. So what is this ARIMA model? Can anyone tell me? What is the expansion for ARMA model? You might have come across this while you are studying the signal processing. Have anyone heard this ARMA model?
Ma'am, auto integrated.
Yes, ma'am. Yes, ma'am. Actually, it is not integrated. It is regressive because
Auto regressive.
Yes, ma'am.
Integrated model, I think.
Yeah, yeah, yes, ma'am. Okay, nice. Auto regressive moving average model. Okay. Okay, so this is a kind of time series. It is a stationary time series with respect to time, as I told you. It is a linear function, I told you. It has its own residual errors also, right? So it is time for us to combine both the auto regression model and the moving average model, what we have seen in the before cells, right? Python book, right? So if you combine both this technique, auto regression and moving average, then the new technique comes that is called auto regressive moving average model, that is ARMA model. So however, sometimes the time series is not stationary, right? So not stationary means what? As I told you, it is the statistical properties of a series, right? Time series like mean, variance, it changes over time. It will not be a stationary. It will not be a stationary one. It is not stationary, right? It's changing over time. And the statistical models we have studied so far assume the time series is stationary. But now my data is of non-stationary. Therefore, we have to include a pre-processing step of differencing the time series to make it stationary. Okay. Now it is very important for us to find out whether the time series we are dealing with it is stationary or it is a not non-stationary one. We have to interpret and we have to know whether it is a stationary data or whether it is a non-stationary data. So if you want to check, there are so many methods, right? For example, we can check the difference in mean and variance. Like there are so many tests.
Ma'am, connection is not there, ma'am. 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 Connection disconnected, ma'am. Yes, ma'am. Now it's okay, ma'am.
Yeah, ma'am. Okay, so because of the network connection. Sorry.
Okay, ma'am. Okay.
Yeah. I'll share my window. So we are going to hybrid these two techniques, right? One is auto regression and another one is moving average. So that's why we are naming this as ARMA model. That is ARMA model. That is auto regressive.
Ma'am, excuse me, ma'am. Sorry for the disturbance.
Yes, ma'am.
One minute. ARIMA model and previous one auto regression model. Two models you told.
Yes,
When we have to hybrid those models, that is novelty approach is there.
Already it came up.
These are all the already used
existing
methods
model.
only.
Yes, ma'am.
Hybrid also used methods only.
Yes, ma'am. Yes, ma'am.
Okay, okay. Thank you.
Yes, ma'am. Yes. So this auto regressive moving average model, we are going to check it out. And I told you, if you want to check whether our data belongs to the stationary one or not, it is a non-stationary one. If you want to check, we have to go for, there are so many kinds of tests are available. One is ADF test, augmented Dickey-Fuller test, and another one is KPSS test, and another one is Hurst component test. So we'll go for with the test and we'll check whether our data set is stationary or whether it is a not a stationary one. So here if you see, yes. So here if you see, here I'm going to take some other data set that is called airline passengers data. Here I have uploaded in the left hand side. You just upload using this folder, using this arrow. Yeah. Now what I'm going to check is, I'm going to check whether this particular data set is stationary or a not stationary one. So for that, again, we need to import the read underscore CSV file, import the data from pandas, and I'm going to import the libraries, stats, models.tsa, stats tools, and I'm going to again, I'm going to import this particular, I'm going to use this test, right? ADFF test, right? So this test is called ADF test. ADF test is augmented Dickey-Fuller test, right? Here I can tell you. Yeah. If you bring your cursor over here, it will show you. Augmented Dickey-Fuller test. Yes. So I'm going to use this particular test to test whether it is a stationary data or whether it is a non-stationary data. Yeah. So I'm going to import a log function from the numpy in order to use over here. Okay. I'm going to upload this particular data. I'm going to read this data, and I'm going to extract the values. Okay. And then I'm going to store it in a variable X, and I'm going to take a logarithmic function, and then I'm going to take this add fuller test over here. So it is an inbuilt function. You can see over here. So this test can be used to test for a unit root in a univariate process. In the process,
Practice. Saroda practice. Saroda practice.
some noise is coming.
இந்த ஒரு படத்துல வரும்ல சாரோட பிராக்டிஸ் சாரோட பிராக்டிஸ்
So participants, you kindly mute your audio.
Participants, it's really disturbing. Can you please mute your mic? Yeah. Ma'am, please proceed. We'll ask the host to mute her.
Yes.
Yeah.
Yes. So I'm going to use this particular inbuilt library function. So no need of worrying what is happening over there inside this ADF statistic and all. So we are going to import this particular library add fuller, and I'm going to store that particular value in the result, and I'm going to print all the values, and I'll show you what is happening over there. Yeah. So here if you see ADF statistic, the value is -10, and my p value is 0, and all the other critical values, it is -3, -2, and -2 respectively. Okay, so now we have run the ADF test, right? Now let us interpret the result first. First we'll compare the ADF statistic with the critical values, and here you can see a lower critical value tells us the series is most likely non-stationary. Lower critical value, for example, if you take 1%, it is -3, right? And for 5% of the values, critical values, it is -2.
ஸ்லோவா தான் வருது இது ஃபாஸ்டா எல்லாம் போயிடுச்சு வெயிட் பண்ணணும் அங்க சுத்திட்டு இருக்கு பத்தியா
And next we'll see the p value. A p value is greater than 0.05. If it is greater than 0.05, now again you can interpret the time series is non-stationary. Okay, if it is 0, probably it is a stationary time series data. So no need of worrying about that. Okay, and you can also alternatively you can go for p value. P value is
13 day 14 15
day value is 1 second.
Ma'am, do you have the accessibility?
Yes, ma'am. Yeah, ma'am. I'm searching for that.
Yes, please, ma'am. I don't have that control now.
Yes, ma'am. Yes, I made it.
0
Again, it is coming. Let me check, ma'am.
Ma'am, can you please remove her from this meeting?
Yes, ma'am. I'll try, ma'am.
Please, ma'am. Thank you, ma'am.
Mama. User. QW activation.
Gomati ma'am, please mute yourself.
Yes, ma'am. I removed her name.
Thank you, ma'am.
Yes, ma'am.
Thank you. Sorry for the disturbance, ma'am.
Okay, no problem, ma'am. So unknowingly, she might have
Yeah, I understood, ma'am.
clicked that button. Okay, no problem, ma'am. Yes. Okay. So now yeah. So you can infer all those informations and you can say whether our data belongs to a stationary time series data or non-stationary time series data. So if it is a stationary time series data, then we have to go for particular algorithms. If it is non-stationary, then we have to go for some other particular algorithms. And you can also tell by seeing the p-value, you can also say whether the time series is stationary or not. So for that purpose, we are taking this ADF statistics. Okay. So what we are dealing the data is which is already stationary, and we'll be knowing already this data is stationary. So no need of getting hectic over here. Yes. So the next is we'll try to fit the model and we'll try to predict. Okay. So for that, let me run this particular cell. So again, I'm using this particular library stat model, and then I'm going to use this. You see here ARIMA, right? ARIMA. It is an inbuilt function, inbuilt library we can use in order to predict the value. In order to predict the value using this statistical model, because this is a statistical modeling, I'm going to use this function, right? So ARIMA function auto regressive integrated moving average model. Here the parameters are P, D, Q, right? And P represents your AR parameters. P, D, Q are the model for AR parameters, and also we are using this MA parameters as well, right? Because we have hybrided all those values, right? And I'm going to take the values from the train data, and then my order is 5, 0, 2, and then I'm going to fit this particular model. For this, the inbuilt function is model.filt. If you run this, it is getting trained. Now using this statistical model, my data is getting trained. Now I'm going to predict. So for that, what we need to do, we need to consider the test data. I calculate the test data, and then you give it as a parameter input argument using this predict function. Now in the variable predictions, my data has been stored, and then I'm going to use this pandas, and I'm going to use this data frame for this test data, and I'm going to store it in a variable test underscore. Okay. Now you can see it is getting predicted. Yes. And I'm going to plot this particular predicted data. Let me tell you. Yeah. Yeah. So this you can very well you can check it over here. This orange color, right? Orange color data is the predicted data. Okay, more or less the same. But if you want to know whether it is exactly fitting or not, or whether it is exactly predicting or not, we'll be able to. It is easy for us to calculate the RMS square. Okay, by calculating the RMS square, we'll be able to tell how much error between the true data and the predicted data. Okay, so we'll calculate that. Yeah, so we'll try to calculate the error between the already existing value and the predicting value. Yes, so it is about 43.21 value. The value is the error is 43.21 for my tested data. Okay, so more or less we are able to catch up with the real data or true data. The target value is matched with the true data or the existing data. So the ARIMA model, it is very well working with this statistical modeling. Okay, and then so far we have seen AR model, MA model, AR-IMA model, and then the last one is the last one is LSTM. Before LSTM, we are going to see the next method, that is called exponential smoothing. Okay, so here in exponential smoothing, again there are two methods: simple exponential smoothing and triple exponential smoothing. Let me tell you what is this smoothing. Yes. So this exponential smoothing is a technique. It is for smoothing the univariate time series. What we are doing with this smoothing is we are going to assign exponentially decreasing weights to the data over a time period. Exponential decreasing means it will be like decaying means like this, exponentially decreasing, right? So it starts from the highest value and it ends up with the lowest value. So we are going to assign exponentially decreasing weights to the data over a particular time period. So this is what happening in this simple exponential smoothing. And in triple exponential smoothing, it is the variant of your exponential smoothing. Here there are so many methods to adopt this triple exponential smoothing. So let me go with this exponential smoothing. Let me run this cell. It is throwing you the error. Again, it is invalid. Okay, let me predict this. Okay, let me plot this. So the error here is might be this particular function will not be there. It is throwing us the error. It is telling us the invalid syntax. So I'm not able to fit this particular model, but it is taking the previous values and it is trying to fit with the model, right? So it is taking all the values and it is just trying to fit with the model. The blue color represents the actual data and the orange color represents the predicted data. So we can calculate the error and then we'll be able to see how much error it is happening over there while using this exponential smoothing model. Okay. So first what we are doing is we have trained the model once with the training data and then we keep on making the predictions by using different approaches. A more realistic approach is to retrain the model after one or more time steps. Okay, we can again we can retrain the model and we can predict. So okay, so as we get the prediction for time t+1 for the training data, the next prediction can be made by using that the previous data. T+1 data can be used for T+2 data as a training data. Okay, the next data can be used as a training for the next data. Okay, so this methodology for making predictions for one or more future steps and then retraining the model is called rolling forecast model. Okay, so we are going to validate the point with by means of this forecasting model, that is forward validation. It means that it is a forecasting model, a forward forecasting model it is. Okay, yeah, so next comes the last model, which is called as LSTM model. It is said to be a recurrent neural network. So if I want to use this deep learning methodology for my time series prediction or time series model, the very well-known network is the LSTM network. So what is this LSTM? Long short-term memory network. Okay, it is a beautiful network which predicts the forthcoming data or whether it is a weather data means for forecasting the weather or forecasting the data or stock forecasting. All these things can be forecasted by using this LSTM model. So far we are familiar with the statistical modeling on time series, but nowadays all are dealing with machine learning and deep learning. Okay, so it is also essential to be familiar with this, familiar with some machine learning models as well, right? So we'll start with this most popular model in time series domain, that is LSTM model. Okay, as I told you, it is a recurrent neural network. So before going into that, you should understand what is neural network and what is recurrent neural network. So this recurrent neural network is nothing but giving feedback then and then, right? So for example, if you give your data, I'm going to give the first input data first. For example, if it is a temperature data, I'm going to giving it to the network. Okay, so the network will get processed. It will give you some output. Okay, and then that output will be taken as input for the next input data. For the second input data, the first output is given as input. Okay, and then the second actual input will also be given to that particular data. So it is called recurrent neural network. Okay, you might have known all what is neural networks, right? Artificial neural network is a layered structure of connected neurons, which is inspired by the biological neural networks. It is not a one algorithm, but combination of various algorithms, which allows us to do complex operations on any data, right? And likewise, neural network, the recurrent neural network is a class of neural networks. It is going to deal with temporal data, that is time oriented data, time series data. Okay. So here, if you want to take up previous output and if you want to give it as an input to the next network, the neurons of RNN it should have a memory and it should have some cell state. So that state is called internal state. It can be achieved with the help of loops within the neural network. So this model is called recurring model. Okay, we can also call this as tan H layers, the tan hyperbolic layers in RNNs, which allows them to retain the information. Okay, however, it is not for a long time. That's why we are calling this as a long short-term memory network. Okay, so LSTM is a kind of recurrent neural network that is capable of learning long-term dependencies in data. Okay, this is we are going to achieve this because the recurring module of the model has a combination of 4 layers interacting with each other. Also, okay, so we'll be using this sigma parameter and also we'll be using this tan H module. Okay, and then it will be repeating further. Okay, so let me run this cell. Okay, so what I have done here, I'm going to use this function numpy function. I'm going to plot a range from 1 to 500 with a step of 1. Okay, so you can see here it starts from 0 to 500 with each step of 1 I am going to plot it. Okay, so I'm going to use this linear equation y is equal to mx plus c. Here m is a slope, 0.4 is a slope, and the intercept is a 30 plus 30 is a constant. If I'm going to plot this, we know that it is a linear equation, and I'm going to plot over here. It will plot you as a linear plot. Okay, now what I'm going to do is I'm going to train this data. Already I'm having this x variable, y variable over there in the previous in the previous cells, right? Let me run this. Yes. So my data have been taken and it is going to split the data for train data and test data. So for training, again the input data will be taken and the output data will be taken, and then it is going to store all your array values in the train variable and all your y values, train values in the test values. All your test values will be in the test folder. All your train values will be in the train folder. Yes. So here, if you look at, right, okay, it is showing some error. So can anyone tell me what is happening over there? Why it is throwing error? Yes. Okay. So let me check with this. Let me check with some other program. Just a second. So for LSTM, I'm going to import the sequential model because it is a sequential learning. And so I'm going to use this Keras model. And I'm going to use this layers, keras.layers. I'm going to import LSTM and also I'm going to import this dense layer. And you need to tell the network what is the kind of learning which we are going to happen here. It is a sequential learning. So sequential of empty bracket. And then I'm going to add 2 LSTM layers and 1 dense layer. So 2 LSTM layers which consist of 256 neurons, and input I have taken the input as train X data is to be taken into the input shape, and then it will be again given to the next layer because it is a recurrent neural network. The next layer is also a LSTM network, and then the last layer is a dense layer. And I'm going to compile the last is mean squared error. I'm going to compile the last, and I'm going to use this optimizer, that is Adam optimizes, or Adam optimizer is taken over here, considered over here, and I'm going to compile this, and I'm going to fit the model for this data, train X data and train Y data. I'm going to use this 2000 epochs and batch size is 10. And here I'm going to save all the weights in this name, LST basic 1.h5. Okay, so let me run this. Expected an indented block. Okay. Okay. So anyway, I'll try to correct this error, and I'll send you this Python notebook over here, so that you can run the program and you can see how this LSTM works on your particular data. First, you work with this given data, and then you work with your own data. Okay. So it will try to plot between the predicted value and the actual data. So it will give you all these values. Yeah, so that's it. Okay. So my dear participants, I'll try to yes. So I'll try to correct this error, and I'll post this particular Python notebook to your coordinator so that you can get from them. Yeah. Okay. So here I'll just narrate what are the things that I have to covered in this particular session. So we have started with what is this time series. So it is a data observation with respect to time, and we have seen the statistical modeling and also the RNN network, which is called LSTM model. So I told you about the languages. What are the languages that we can use it for time series modeling? And then I have discussed some of the Python libraries, what we are going to use it, what we have used over here. And then I told you about how to process the data and how to visualize the data. So visualization and interpretation is very important for any kind of data, particularly time series data. And I told you how to check by using this Duckler-Feller test, how to check whether the time series is stationary or not non-stationary. Okay, and then how to drop the NaN values and how to create a date time object and how to plot all over the things and how to make a box plot, right? And then I told you we have just discussed about the 4 components that we have seen, right? For time series, level, trend, seasonality, and noise are the 4 components which we have to consider. And we have seen the naive methods, auto regression methods, moving average methods, and then the hybrid technique of these 2, ARMA model, that is AR-IMA model, and then we have seen this exponential smoothing, and then the last is the deep learning network that is called LSTM network. So long short-term memory model it is. Okay, so that's it from my side. If you have yes, ma'am. If you have any questions, you can.
Yeah, participants, please unmute yourself for clarifying your doubts. If you have any question, you can put them in chat box or you can unmute yourself and ask.
Great, mom. Well done, mom.
Pardon?
Very interesting session, mom.
Okay, thank you. So you belong to which department? Statistics or
computer engineering?
Engineering.
I'm from Laduka. Yeah, I'm from Ladu Capital University of Technology.
Oh,
AICTE-ISTE-IFETCE-CSE, Nigeria.
Okay, fine.